Hey yo, welcome back to the AAHL M25 Time Zone C Paper 1. Now we're gonna have a look at questions 6 to 9. So for question 6, you're given a graph of a rational function and you're asked to sketch the various transformations. So in part A, you're asked to sketch the graph of y equals the absolute value of f of x. So we all know what to do here, right? Because we're taking the absolute value of the entire function, all the stuff that is below the x-axis will now be reflected over the x-axis, and all the stuff that is greater than 0 will remain as is. So the asymptotes, the vertical asymptote will remain as is. So let's do that first. This guy will stay at -1/2. The part of the slant asymptote that is greater than 0 will remain as is. Point B is at 0 and 7.5. That will stay as is. And this section of the curve will remain as is. The tricky part is to handle the other parts. Point A was at -1, -5/2. Reflecting it over the x-axis, we now have -1 and 5/2. The part of the of the slant asymptote that was below the x-axis are also reflected. This is the trickiest part of the question because a lot of students would have omitted this asymptote over here. And from here you have all the information required to finish the sketch. So it's gonna go from the top, following the slant asymptote all the way down to the minimum, going back up. This is point A, this is 5/2. The equation of this line over this slant asymptote is 5x plus 5. The equation of the other one, that would be -5x minus 5. In part B, you're asked to sketch the reciprocal. So for reciprocal, what's the first thing you should always do? Roots become asymptotes. Asymptotes become roots. Does f have any root? No. Does it have any vertical asymptote? Yes, at -1/2. So we're gonna put it here. This is still 5, that is still 10. Okay, that's pretty good so far. What else? Point A was at -1 and -5/2. Now becomes -1 and -6. What else? Point B was 0 and 15/2. Now becomes 0 and 2. What else do we have to pay attention to? Okay, now we can basically finish off the sketch then. Let's look at this part. I'm going to divide it up into several parts. The first part is from -30 to -1. Then from here to there, let's say from between A and B, and then from here onwards. In the first part, we are close to -30. 1 over a very big number is close to 0. 1 divided by a very massive number is gonna be 0 minus. It's closer to 0, but on the negative side. So the first part of the curve would look something like this. It gotta pass through A, then it's gonna go up through the root, then through B, and now we're gonna take care of the last part. We are now at this point. As x gets bigger, y gets bigger. 1 divided by a big number is 0. Thus, it will decrease until it is asymptotic to the y-axis. Oh, sorry, to the x-axis. So the horizontal asymptote is y equals 0. This is part A, that is part B. And that is the end of question 6. This is a time sunk, people. If you don't know what you're doing, do not spend hours on this, okay? It is fine, do what you can, but sketching these crabs properly can take 10 minutes easily, and you do not have such time to waste. Question 7. If we are rotating about the y-axis, we know that the formula is gonna be integral of x in terms of y squared dy multiplied by pi with a lower bound and upper bound. This is our lower bound. That is our upper bound. X squared of in terms of y, that is trivial. That is y to the 4 minus y to r to the 4 minus y to the 4. Don't forget the pi. What is our upper and lower bounds? At these values, x is equal to 0, so y to the 4 is equal to r to the 4, so y is equal to plus or minus r. So this lower bound is negative r, that upper bound is r, as r is positive. And now you just have to evaluate this very simple integral. So, integrating r to the 4, that will give you r to the 4 times y. Integrating the second term, that will give you y to the 5 divided by 5. Plug in the bounds. So pi times r to the 5 minus r to the 5 over 5 minus negative r to the 5 minus negative r to the 5 divided by 5. And that will give you pi times 2r to the 5. There are too many minuses. Minus 2r to the 5 divided by 5. Or 8 over 5 pi r to the 5. End of question. Question 8 concerns complex numbers. In part A, we're simply asked to express z1 in exponential form. This is 3 marks. In part B, we are asked to find the cube roots of z2 divided by z1. So let's start with part A. R is going to be the square root of root 3 squared and negative 3 squared. It is the modulus of the complex number. And you will get 2 root 3. What is theta? And how do we find theta? I always tell my students to quickly locate the complex number on the organ diagram. Negative 3 is here. Root 3 is somewhere over here. Your z1 will be somewhere over there. The argument of z1 is going to be this angle. So, theta, that's going to be the arctan of negative 3 divided by root 3, and it should give you negative pi by 3, which makes perfect sense. Therefore, z1 is 2 root 3 e to the negative pi by 3 times I. Easy peasy. Part B. We are now asked to find the cubic roots of z2 divided by z1. So Z2 divided by Z1, that would be 2 root 3 e of I 5 pi by 6 divided by 2 root 3 e to the negative pi by 3I. That's gone. So we would get e to the 5 pi by 6 plus pi by 3 times I, or e to the 7 pi by 6 I. And the cubic roots are therefore, the first root, doesn't matter which one, the first root is e to the 7 pi divided by 18. Sorry, it's e to the 7 pi divided by 18i. Or roots of this equation are equally spaced out. So the argument of the second complex number is gonna be e to the 7 pi by 18 plus 2 pi by 3. And the argument of the third one will be 7 pi by 18 minus 2 pi by 3. Et voila. So you would get this guy. In the second case, you would get e to 19 pi by 18, or it can also give you answer as e to negative 17 pi by 18i. That is also correct. And this one is simply e to negative 5 pi by 18i. So those are the three roots. Question 9. I do not know why this is question 9. So at first glance, we know for sure that we're going to use L'Hopital. That is the only technique we have seen in the course. And how we know this? If we substitute x equals to 0 into our limit, the numerator will be 0. The denominator will also be 0. So it is in the 0 divided by 0 form. This means that L'Hopital can be used. If L'Hopital can be used, we're going to differentiate the numerator. That will give you sine of x plus x cos of x. We can also differentiate the denominator, sine of x. First application of L'Hopital rule still leaves us with an indeterminate form. Still in the 0 divided by 0 form. So we're going to use L'Hopital a second time. It's going to be cos of x plus cos of x minus x sine of x divided by cos of x. And now we would get 1 plus 1 minus 0 divided by 1, or famously known as 2. And that is the value of our limit. Thank you for watching, and I will be back with another video on section B.